What up, mathletes? Whoop, whoop. All right. This is 2.5 for Math 2. Our learning target is I will recognize and apply the properties of rhombi and squares. And our warm-up is determine whether each pair of lines is parallel, perpendicular, or neither. I said, remember, parallel equals same slope. Perpendicular slope, that perpendicular means perpendicular slope, is negative reciprocal, or the negative flip of each other. And slope in general is just your y2 minus y1 over x2 minus x1. Go ahead and take a minute. Solve for, or I guess we could add to there too, y equals mx plus b. And I guess that is for the points x1, y1, and x2, y2. Boom. Get that all written down. Pause this, solve these, all four, ready, set, go. All right, now it'll bring me back into the picture. Let's do this. I'm just going to point it back. So our slope 1 is going to be what? Negative 6 minus negative 3 all over negative 4 minus 8. So that's going to become plus 3, which equals negative 3 over negative 12, which is 1/4. Okay. Our slope 2 is going to be negative 3 minus 13 all over negative 3 minus 1. Which equals negative 16 over negative 4, or positive 4. Now, this is the flip, this is the reciprocal, but it's not the negative reciprocal. So because of that, this is a neither. This is not the same, it's not the negative reciprocal, it's neither. It's not perpendicular or parallel. We're going to do the same deal over here. M1 is equal to negative 4 minus, right? I'm going to point it back to here, negative 1, all over negative 3 minus 2. That becomes a plus. Negative 4 plus 1 is negative 3 over 3 minus 2 is 1, which equals negative 3. And slope 2 is 0 minus 6 all over 3 minus 1. Equals negative 6 over 2, which equals negative 3. Same slope. Parallel. So it means they are parallel. Okay? All right, let's take a look at these two right here. Solve for y. So this one right here, that is the slope. So m1 equals 2. We just solve this for y. Divide both sides by 2. I'm going to divide each term by 2. So I get y equals negative 1/2 x minus 1/2. Slope is negative 1/2. M2 equals negative 1/2, which this is 2 over 1. That negative 1/2 is the negative reciprocal of 2. So these are, what do we know? Perpendicular slopes have the negative reciprocal, so these are perpendicular. And last but not least, again, solve for y. Minus 4x, I always put that first. Negative y equals negative 4x plus 2. So therefore, y equals positive 4x minus 2. And that's our m, so m1 equals 4. Should be squaring my answers at the very least. M2, I'm going to subtract 8x. Subtract 8x. 2y equals negative 8x minus 6. Divide both sides by negative 2. And I get that y equals positive 4x plus 3, which gives us a slope m1 equals 4. These are parallel. Or square. Be consistent. Boom, look at that, good stuff. All right, we got lots to write down, guys. A lot of today's lesson is writing down. Remember to pause things as they come up. I'm just going to put this down on mine. We'll scroll up from here. Take a minute, pause this, write it down. A rhombus is a parallelogram. That's what that stands for, with all four sides congruent. A square is a parallelogram with all four sides and angles congruent. Let's scroll up. Again, I'm assuming you're pausing a lot of this. Theorem 7.15, diagonals of a rhombus. If a parallelogram is a rhombus, then its diagonals are perpendicular. So they're going to form a 90-degree angle in a rhombus. All right. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So what can we say? Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And we have angle 5 is congruent to angle 6. And angle 7 is congruent to angle 8. Boom! Good stuff, guys. And we already know that opposite sides of a parallelogram are congruent. So 5 could equal 7, 6 could equal 8, all that good stuff. Awesome. Let's go ahead and use these facts to work out some problems from the other side. Take a minute, use what we just learned to try to solve these. I'm going to take a quick drink of coffee, then we'll get right into it. All right, let's do this. Quadrilateral DEFG is a rhombus. Find the values of each measure. Well, what if the measure of angle DEF right here is 78 degrees? Find the measure of angle GFR right here. I've got a kind of unique way to do that. First of all, if that's 78 degrees, I know that this angle DGF is also 78 degrees. And since this is a perpendicular, we know that this is a rhombus, and therefore this is a bisected angle. So what's half of 78? Let's see, 35 plus 4, 39 degrees. So I know that this half right here is 39 degrees. And go with me. The angles of a triangle, if I just look at this triangle right here of GFR, I look at just that triangle, I know the angles of a triangle add up to 180. 90 of them are right there, which means these two angles add up to 90, because 90 plus 90 is 180. So all I have to do is say 90 minus 39, which is 51 degrees, is the measure of angle GFR. Look at that, not bad at all. How about this? What if I know that EF equals 3x minus 2 and DG equals x plus 10? By DG, well, what do I know about opposite sides of the parallelogram? Or a rhombus? I know that they're congruent, so I'm going to say that 3x minus 2 equals x plus 10. And let's just carry this out. Minus x plus 2 plus 2. 2x equals 12. X equals 6. Okay, let's plug that into, doesn't really matter which one, but it says DG, so let's do that. So DG equals 6 plus 10, which equals 16. Boom. Again, I'm assuming you paused this, attempted it. What about GR? And is 2x plus 12. Now what I find? And RE is 4x minus 10. And I want to find out what the whole thing is. So first of all, I know that these lines are congruent to each other. They're just cut in half. The whole GE was just cut in half. So I'm going to set them equal to each other. 2x plus 12 equals 4x minus 10. So I'm going to subtract 2x from both sides and add 10 at the same time. Because why not? That's gone. I get 22 equals 2x, or 11 equals x. Great job. So now we need to find what the whole thing is. So I'm going to plug it into just one of these sides. So let's go right here, 2x plus 12. So GR, or what I know is GE, the whole thing from end to end, is going to equal 2 times GR, which equals 2 times 2x, which was 11, plus 12. See how I'm just multiplying it by 2, so I get 1 and 2 since they're both the same size. This is 22. I get 22 plus 12 is 34, so I'm going to have 2 times 34, which equals 68 long. Boom. It's a good problem. All right, let's go on. We've got some other good examples here. Take a minute, read it. The diagonals of rhombus KLMN intersect at P if the measure of angle LMN, is this whole thing again, is 63 degrees. Find the measure of angle KLP, so it's this angle right here. Where again, I know this whole angle is 63. If that's true, this half angle right here is just 31.5 degrees, right? Same as this one. So now, being a rhombus, I know that these are perpendicular, right? So right here is 90 degrees. These 3 angles add up to 180. So I know these 2 angles are just add up to 90. So 90 minus 31.5, add a 0.0 there. What do we get? Got to borrow 8, 10, 10 minus 5 is 5. 9 minus 1 is 8. And 8 minus 3 is 5. 58.5 degrees. Not too bad. And our last but not least example is BCFD is a square, okay, with BC equals 2x plus 5. And FD equals 47. GD equals, where's GD? X plus 12.5. 25, excuse me. Find BC. Well, BC, it's a square, so BC is the same as FD, so BC equals 47. CD is also 47. It's a square. I got that. GD. All right. So to do this, I got to solve for x. To solve for x, so for GD, we got to start off with, we know BC is equal to FD. So that means 2x plus 5 equals 47. I don't know why I drew that line. We're going to subtract 5 from both sides. I get the 2x equals 42, divide that by 2, and we get x equals 21. Now, that's just x. I got to plug x back in to get GD. So GD is x plus 12.5, so 21 plus 12.5, or 12.25, excuse me. And it's going to be what? 33.25. And then last but not least, we want to find BD, which is just the whole thing, or 2 times 33.25, which equals 66.5. Yeah. All right. Last but not least, guys, we've got a little bit of writing left. Just going to scroll down through these. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So if the diagonals are perpendicular, it's a rhombus. If the diagonals bisect opposite angles, like this one does, then it's a rhombus. Now this one, 7.19, is a little different. Again, pause this and write things down, guys, as I'm going, so you don't miss anything. So when you pause. For theorem 7.19, if two consecutive sides of a parallelogram are congruent, so two consecutive sides are congruent, then the parallelogram is also a rhombus. There we go. And then last, if a quadrilateral is both a rectangle and a rhombus, so same sides, but it's a rhombus, then it is a square. If RSTU is a parallelogram where RT equals ST equals TU equals UR, that's just the sides around, they're all equal, and the measure of angle R equals angle S equals angle T equals angle U, which all equal 90 degrees each, then RSTU is a square. Boom. Again, pause these guys, write them down. With that said, peace out.